Hey everyone, this is Landon with Viator DSP. I'm the audio programmer and I'm here with the DSP tutorial. So in this video, we're going to talk about the process block, how to capture and process audio, using audio blocks in the DSP modules, and so much more. Alright, let's get started. Okay, so to start off, I'm just going to show you that I already have a dial and little plugin UI made. So I have a smooth value called volume, and that's what we're going to use to change the volume of our plugin. And the UI is just calling on value change on the slider. And we're setting a target value for the smooth value, and that's just the gain slider's value. We're also calling reset in the prepare to play method, and we're resetting it with the sample rate, and then this is the time in seconds to ramp so that you don't get pops and clicks. So 0.02 is going to be 20 milliseconds, and here we go. Here is the process block. So this is where the guts of your audio processing is going to happen. So how does the process block work? Well, basically it's capturing a block of audio samples from your DAW. So depending on what that setting is in your DAW, you know, it could be 32, 64, all the way up to 1024, maybe even more in some other DAWs. And basically what's going to happen is the process block is going to run through those samples, that block, and it's going to happen sample rate divided by block size times per second. So if I pull up my calculator, we can pretend, let's say our sample rate is 44,100. And we're set to, I don't know, 128. So it's going to run 344 whatever times per second. So the process block isn't running 44,100 times a second. It's actually running that divided by your block size, which makes sense because basically the process block, the way it's set up by default is just processing the entire block, not sample by sample. So we can process sample by sample, and that's what we're going to do now. So by default, it sets up this for loop that's looping through your channels. And by default, it's 2 channels. So it's stereo. So we have access to channel data inside of this channel loop. So the channel loop is going to run twice, and we have access to this channel data, but we need to have access to it at every sample. So we need to make another for loop, and that's going to be based on the samples. So I'm going to say for. This time it's going to be sample. So we'll say int sample equal to 0, and we're going to want to loop through it how many times, the buffer, the sample size, right? So we'll say sample less than buffer dot. We have a couple of options. If you type in num, you can see that you have access to num samples and num channels. So let's do samples, and then we need to increment the sample every time it runs. And now this for loop is going to run. So let's see, we have, what did I say? Let's pretend we have 128 sample size block. So this loop is going to run 128 times on each iteration of the channel loop. So it's going to be every sample in the left channel and every sample in the right channel. Okay, so how do we actually do something to the audio? Well, we have this pointer reference right here to channel data, and that's pulling from the right pointer of the buffer, which just means that it's something that you can write to. So you're not going to be actually filling the buffer with new information. You're going to be replacing what's in there already. So if we pull channel data right here, remember we have access to the index. Right now it's called sample. So we can actually say sample so that we have channel data at every sample. And then we can do whatever processing we want. So let's change the volume. Well, to change the volume of an audio signal, you just multiply it by a number. Like I said, I already have a smooth value set up right here that's coming from the slider. So when you have a smooth value as opposed to a regular float or double or something like that, whenever you want to get the value of it and use it, you call volume, and then it's called get next value. Cool. But our slider is actually set to -96 to +48, and that's in decibels. So we don't want to multiply the sample data by -96 or +48. That would be ridiculous. So what we need to do is scale it to a logarithmic scale. So Juce actually has something built in and makes things really easy. So we've got Juce, it's in the decibels. We've got decibels to gain. And now we can put our get next value in there. So now what's happening is we're taking whatever's in channel data at the current index of our sample loop, and we're just multiplying it by our volume. So let's see if that does anything. Gonna go ahead and build it, open it in Logic. Okay, and here's the plugin, just a nice little dark UI. I've got a phase button and a dial. Like I said, the dial goes from -96 to +48. So let's go at 0. So at 0 decibels of gain, you should have no change. So it should be multiplying the signal by 1. So let's just check that. Cool, and let's move the dial around. And we've got some volume reduction, good. We can pull it up, yeah. And then, like I said, this is a smooth value, so I should be able to move it around quickly like this and not get any pops and clicks. So let's check that. Yep, it's working. Okay, so what is kind of at a lower level, what is multiplying the signal actually doing? So if we go over to Desmos, the online calculator, I've plotted a sine wave right here, just from -1 to 1, just like our input capture from Juce. And I'm multiplying it by B, which is just a slider in Desmos. And I've got it from 1 to 4, just as a quick check. So you can see that whenever you're multiplying the signal by 1, it's not doing anything. We still have a Y range from -1 to 1. But if I increase the volume, or if I increase the multiplier, yeah, you can see the waves start to move up. And at 2, we've multiplied it by 2, yeah, that, cool. So let's do something else. So let's do the decibels to gain conversion, and we'll see what that looks like. So basically, you would do 10 raised to the, let's see, to the value from the slider divided by 20, and that's the, divided by 20. Okay, so we need to make this from 0 to 4 now. But let's make it 0 to 24. Okay, so at 0 dB, we're getting no change, and that's because 0 dB with this formula equals 1, so we're multiplying the wave by 1 and nothing's happening. But watch whenever I pull it up. So as we approach the middle, the change in the waveform is somewhat linear. And then as we get to the middle and then higher, you can see that the change is more pronounced and it gets larger and larger. And that's the logarithmic feel of this equation. Now, something else we can do in Juce, really simple in the sample loop, is we can flip the phase of the signal. And we could do that by just multiplying our signal by -1. And that will flip the phase, and we could check that pretty easily in Logic to make sure that it's working correctly. And then we'll go over to Desmos and I'll show you what's happening there. Okay, so we have the signal being multiplied by -1, and we shouldn't hear any change by itself. Let's play this real quick. So we don't really hear a difference, but the difference is going to come from duplicating the audio and putting the plugin on only one of them, and I'll show you what I mean. So let's duplicate our channel. Copy and paste the same sample, and we'll take the plugin off of this one so that there's no difference, and we'll leave the plugin on this one so that it's being multiplied by -1. And what should happen is they should cancel out. We should hear silence. So let's make sure that works. Ha! Silence. So if I turn the plugin off, it should come back, and then I turn it back on and the phase is flipped and they cancel each other out. So let's check that out in Desmos. Okay, so I've plotted two different sine waves. One is red and one is green, and they're on top of each other because they're both just the sine of X. And we're not really seeing anything different because, like I said, they're the same value. But I'm gonna start to add a multiplier approaching -1 to this should be the red line, and let's see what happens. Okay, so I'm multiplying it by 0.9 and the volume is going down is what it just looks like. So we can now see that there's 2 waves. And let's see what happens when we get to -1. Okay, so when we get to -1, they're the inverse of each other, right? So what's happening? Why is it canceling out and creating silence? Well, let's look at the Y values for each one. So let's pick a random point. Let's just pick this one. So the Y value looks like it's probably around 0.5, something like that. So we've got positive 0.5 and then the same value, but on the other side of the x-axis. So it's -0.5. So the combination of those two equals 0, right? So let's take another point right here, 1, and at the same position on the y-axis, it's -1. And again, it's the inverse. So they cancel each other out, they create 0. And if you do that across the entire wave, you'll find that every combination of y values, so here, here, here to here, and here to here, they all sum up to 0. And that's why the waves cancel each other out whenever you multiply 1 by -1. So that's a really simple way to flip the phase, which is a very common button or operation to have in a plugin. But all you really have control over is just flipping it completely. You don't really have control of shifting the phase. You just have control over inverting it, which is useful for a lot of applications. But being able to shift the phase over is a really cool thing that we could talk about later. But yeah, that's how that works. So let's do the same thing we did here, but let's do it with the audio block instead of the buffer. So you can see right here, we've got a reference to the buffer's right pointer, and then we're pulling the samples from the buffer. So let's do this with the audio block instead. So I'm going to make an audio block first that references the audio buffer. It's in the DSP namespace of type float, and we need to pass it the buffer. Okay, so now we have an audio block that references the buffer, and this is really convenient if you want to use the included Juce modules, the DSP modules. But let's just make the same kind of channel and sample loop. So I'm gonna actually just pull this right here. And we're gonna now reference block instead. So block.getNum channels, okay. And then let's take the sample one. And we've got block.getNum samples. But we also need this channel data variable right here, but we need to use the block version of it, or the audio block version of it. So we will say block. You know, sometimes when you're doing stuff like this, trying to use the framework, you can just type the variable that you're trying to do some kind of processing on and type dot and kind of see what comes up. You could check the documentation, but if you kind of already have an idea of what you're doing, you should be able to find it. But the documentation is a great resource. So let's type block and then type dot and see what our options are. Here we go, get channel pointer. And then we need to pass it the size of channels. So we'll just pass it channel since we already are using that in the for loop. Okay. And then we can take our same processing, put it in here, and then let's build it and make sure that it works in Logic. Okay, here's the plugin, and let's see if our processing is working. Yep, still working. So it still works with the audio block loop version. So you might be wondering why I would use the audio block loop over the buffer loop version, or vice versa. And it really comes down to what else is going on in your plugin. So let's say I'm using a bunch of Juce DSP modules, And the way you would use it is to call process and then pass it a context. And I might want to also include my own DSP, so maybe a soft clipping or something like that. And if I did that, I could extract my audio block loop into a class of its own and call it soft clipper or something like that. And then what I would do is in my process block, along with the other Juce DSP modules, I would set it up where my audio block distortion process takes in an audio block, and I would call soft clipper.process, and then I would pass it the audio block. And that way the process block is kind of set up the same way. I'd have my Juce DSP module calls, and then I'd have my own that uses an audio block, and it kind of just looks more uniform and it's just more convenient. So how do we actually use a Juce DSP module? Well, it's actually not difficult. So I'm going to erase all of this, and I'll show you real quick. We can go to DSP, and let's look up something really easy. Let's use the gain one. Where is the gain? Right here. So you've got a couple of methods. You can set the gain, whether that's linear or decibels. You can set the ramp duration, kind of like we were using the smooth value. The gain module has a smooth value inside of it already. And we can call prepare reset, and then we can process with the process context, and I'll show you how to do that. So let's set up another value since we don't need to use the smooth value. So let's just do, sure, gain. And then I'm going to go into my UI, and I'm going to change this on value change to gain is equal to gain slider dot get value. Okay. And then what do we need to do? We need to make a gain object. So it's inside of the DSP module. It's called gain. We'll pass it the sample type float, and then I'll just call this gain module. Okay, that should work. A couple things you always have to do for a DSP module is you need to prepare it. So we can go into the prepare method, and we're going to need to pass it a process spec. So let's do that. So we need to create a process spec, and that's also in DSP. Here we go. Process spec. We'll call it spec. And then we need to pass a couple of things to spec. Sample rate, and we'll pass it. We already have the sample rate coming in, so we can use that. We can pass it a maximum block size. And the same thing as the sample rate, we're already pulling in samples per block, so we could use that. And lastly, we need num channels. So we can call spec num channels, and we can set that equal to total num input channels. And that's all we need. So now we can actually call prepare on the gain module. And then it wants us to pass it a process spec, and we just made that, so we'll pass it spec. Cool. So we have this block, so we'll need to call process on it. See, we've got process and we've got process context is what it's asking for. So we can say gain module dot process, and we need to pass it a process context, and that's also in DSP. So Juce DSP process context replacing. And like I say, it's called process context replacing because we're replacing what's in the buffer already, and in this case it's the block that's referencing the buffer. So the type is float, and then all you do is create another pair of parentheses, and then you pass the block that you're using in the process block, and that's it. Now you're processing the audio block with the gain module, and the only thing left is we have to connect the gain to it. So there is a method called set gain decibels. So we don't even have to convert it ourselves. So we can just put this in the process block for right now. We'll say gain module, set gain decibels, and then we have gain. And that's it. It should work. So let's recap real quick. We created a gain object called a gain module. You have to prepare it. All DSP modules need to be prepared. So created a process spec, and we just set the sample rate, maximum block size, and the number of channels. And then we called prepare on the gain module with that spec we created. We called process on the audio block with the gain module, and we're passing it a process context replacing because we're replacing the information that's in the buffer or the block. And then we just need to call set gain decibel so we can actually change the gain of the gain module. So let's build that and make sure it works. Okay, let's see if it works. Sure seems like it works. There we go. So, what other DSP modules are there real quick? Let's back out. So you have all of these DSP classes inside of Juce's DSP namespace. And there's a lot of really cool stuff and easy to use. So some of the ones that I've used that are just as easy as gain in terms of you just call prepare, process, and then set the variables that you want to change. You've got bias if you're doing some kind of distortion, which is cool. You've got the ladder filter. You've got the noise gate, the phase. So the phase will allow you to actually change the phase from 0 to 360 degrees, which is really handy. You've got chorus and compressor, which are really easy to use. The convolution is easy to use. There's just a couple of extra things you have to do with files. You've got filter, gain, the Linkwitz-Riley filter. It's really easy to use. That can be a high pass, low pass, or all pass filter, which is very handy. The panner and the phaser are really easy. Let's see some other things I've used. The limiter, the oscillator. Here's process spec that we used. And the reverb. The reverb sounds awesome. You really don't even need to write your own reverb. This included reverb is awesome. And you can kind of look around and explore the other DSP modules. There's a lot of really good stuff in here, and Juce just makes it so simple and easy to understand. And that's pretty much it for this video. That's our introduction to DSP with Juce. So like I said, a couple of things to remember. The process block is pulling in the block size from your DAW, so 64, 128, whatever it is. It's processing it, and what you would do is you would grab those samples, the buffer or the audio block, and you would replace what's inside of it, either using a channel and sample loop. You can use an audio block and do a similar channel and sample loop. And then you could also use the DSP modules where you would pass the block to the process context replacing. If you look up distortion algorithms, which is basically just mathematical equations, you can just apply that to the sample that you're pulling in from the sample loop. And it's really not difficult to get started and kind of poke around with your own DSP. So that's going to be it for me. Don't forget to like and subscribe for the audio programmer. You can also check out some of my work. My free plugins are available on Patreon. I also live stream Juce development on Tuesdays and Thursdays at 5:30 Central Standard Time, and that's at Dr. Bruisin at Twitch. You can also follow me on Instagram, Facebook, and YouTube with both Viator DSP and Dr. Bruisin. Okay, thanks for watching. See you next time.